Hi everyone. Today we'll be talking about confidence intervals and significance tests for the slope of a regression line. First, we will go over how to construct C% confidence intervals with the state, plan, do, conclude procedure. For the state step, we state that we are trying to estimate the slope of the population regression line with C% confidence, where they give you the value of C. For the plan step, we state that we're using a t interval for the slope of the regression line and check conditions for performing inference. The 5 conditions can be remembered using the LINER acronym, which stands for linear, independent, normal, equal standard deviation, and random. The linear condition is checked by making sure there is no obvious pattern in the residual plot. The independence condition is checked using 10% condition, meaning the sample size must be less than or equal to 10% of the population size. Also, we must be able to assume that knowing one data point does not affect the others. The normal condition is checked by showing that a histogram of residuals shows no strong departures from a normal distribution, or that a normal probability plot of residuals is linear. The equal SD condition is checked by making sure the vertical spread of the residual plot is about the same throughout, for each value of x. The random condition is checked just by stating that a randomized sample or experiment was conducted. For the do step, we will use the formula for confidence interval seen here. In this equation, b is the sample slope, t star is the value of t for the given confidence interval with df equals n minus 2. Note that a common error is using df equals n minus 1, but we must use df equals n minus 2 for regression. The value of SEB, the standard error of the sampling distribution of the slope, is the SE coefficient value in the row of in the computer output with the explanatory variable. In this case, the value is 0.057. Plugging these numbers in gives you the appropriate C% confidence interval. For conclude, we state that we are C% confidence that the interval calculated captures the true slope of the population regression line.
For significance tests, the procedure is very similar to that of confidence intervals. Normally, questions that require significance tests will ask if there is a linear relationship between two variables. For the state step, we will state our pair of hypotheses. The null hypothesis would be beta, the population slope, is equal to 0, since there is no linear relationship. The alternative hypothesis would be beta is greater than, less than, or not equal to 0, depending on if it is asking for a positive, negative, or any linear relationship. We also state what significance level we are using and make sure to define your variables. For plan, we must check the same liner conditions that we did for confidence intervals: linear, independent, normal, equal standard deviation, and random. Is it okay? For the do set, we must first calculate the test statistic t. This is given by the formula here. B minus beta over SCB, where B is the sample slope, beta is the population slope stated in the null hypothesis, and SCB is the same value from the computer output that we talked about for confidence intervals. In this example, the value for SCB is 0.057. And to get from a t-value to a p-value, use a t-distribution of n minus 2 degrees of freedom, and look at the chart. For the conclude part, if the p-value is greater than alpha, then you fail to reject the null hypothesis, and then if the p-value is less than alpha, then you reject the null hypothesis. Don't forget to conclude in context.
Now we will talk about how to interpret the computer output for regression lines. Remember that the least squares regression line has the equation y hat equals mx plus b. From the computer output, m is given under the coefficient column and the constant row seen here. B, the y-intercept, is given in the coefficient column and the row with the explanatory variable. In this case, it's 0.164. SEB, which we use for confidence intervals and significance tests, is given under the SE coefficient column in the row with the explanatory variable. In this case, it's 0.057. T and P in the explanatory variable row are the T and P values for the significance test for slope. Some problems may ask you to interpret S and SEB from the computer output. To interpret S, the standard deviation, we see that when using the least squares regression line to predict the response variable, the true value will deviate on average by a value of S. To interpret SEB, we say that if we repeated the sample or experiment many times, the slope of the sample regression line would vary by a value of SEB from the slope of the true regression line.
Now we're going to talk about transforming nonlinear data. Sometimes after sampling our data, we find that it is not linear. We can transform it via a power or exponential model to a linear relationship, which we can make inferences on using these procedures above. To decide which one to use, make a residual plot for ln(y) versus ln(x), corresponding to a power model, and ln(y) versus x, corresponding to an exponential model. The residual plot with more random scatter is the one for the transformation we should use.
Next, we'll be going over some common mistakes and errors. First, when reading your computer output, make sure to not confuse your data for the slope and your data for the constant. Make sure to always define your variables, and make sure that your degrees of freedom is n-2 instead of n-1. Next, there are times when your computer output is not given, and only a data table of x and y values is provided. In this situation, you can use your calculator to construct a confidence interval or perform a significance test. Using the calculator allows you to avoid errors in calculation, but remember to always report your procedure, test statistic, p-value, and degrees of freedom. Enter your x values in list 1 and y values in list 2 under stat edit. In stat tests, select linear regression t-interval for confidence intervals or linear regression t-test for significance tests. Adjust your values according to the problem and then hit calculate.
For further practice on this topic, check out the 2018 AP Stats FRQ question number 1. Thanks for watching.